Welcome to Catalyst Method, where we ignite understanding and make learning easier. In our today's class, we'll be looking at chain and product rules under differentiation. We know that there are different techniques of differentiation. There are differentiation using first principle. There is power rule, quotient rule, chain rule, and product rule. So in today's class, we'll be looking at the chain and the product rule. The chain rule is a technique used for differentiating a function that are usually more than one. If you are having any function more than one, you can usually solve it using the chain rule. While the product rule is used for finding the derivative of a function multiplying each other. For the chain rule, the formula for chain rule is your dy dx is equals to dy du multiplied by du dx. This is the formula that we'll be using if you are solving for chain rule. Your dy dx will be equals to dy over du multiplied by du over dx. This formula is what we'll be using if you are solving any question on the chain rule. And what is our u here? Our u here is what we substituted one function with. And the function that can be substituted with u is any function that contains x. So for the product rule, the formula that we can use to solve the product rule is if you are having two functions together. For example, if you are having f of x equals to u multiplied by v. U here is multiplying our v. Then our derivative of x, we know that the derivative of x is still the same thing as dy ds. Will now be equals to du derivative of v, that is v prime, plus v multiplied by the derivative of u, that is the u prime. This is the formula we'll be using for product rule. uv prime plus vu prime, where v prime and u prime are the derivative of u and v respectively. Now let's solve some questions under chain rule as well as product rule. Okay, the question said that differentiate the following using chain rule. Our first question here is, the question 1 said y equals to the root of 3x plus 5. Y equals to 3x plus 5. We should know that if you are having roots like this, if you are having a root, is still the same thing as a raised to the power of 1 all over 2. So we have to transform this root into this form. It will now be, our y will now be equals to 3x plus 5 raised to the power of 1 all over 2. We have transformed the root here into 1 all over 2. I will say that the formula we'll be using is our dy dx will now be equals to dy du multiplied by du dx. So how do we get our u? Since we are having u here now, we will get our u by substituting any function with x by u. So in this case now we can see that we are having 3x plus 5. All this inner function here is the one that we will substitute with u. Because here I will say that you can be using chain rule to solve a question if you are having more than one function. Here we are having more than one function. This is our inner function, this is our outer function. So since it is the inner function that has 3x plus 5 or that has x in it, we will make it to be our u. So from here, we will now say that let u be equals to 3x plus 5. And we will be having y will now be equals to u raised to the power of 1 all over 2. Because our u is already 3x plus 5. This one and this one will not change anything. Here we will differentiate u to respect to x, we will differentiate y to respect to u, so that we can get dy du and du dx. So differentiating u to respect to x will now be having du dx will now be equals to, if you differentiate 3x, you have 3. If you differentiate 5 or any number or any constant number, you'll be having 0. So the derivative of 3x plus 5 will give us 3. So our du dx is now 3. We will differentiate y again in respect to u. So our dy du will now be equals to, we will differentiate u raised to the power of 1 all over 2. we know that we have u raised to the power of 1 all over 2 minus 1, which will now give us 1 all over 2, u raised to the power of, if you do 1 all over 2 divided by minus 1, it will give us minus 1 all over 2. So our dy du is now equals to 1 all over 2, u raised to the power of minus 1 over 2. Substituting it in the formula, which is dy dx will now be equals to, our dy du is u raised to the power of minus 1, u raised to the power of minus 1 all over 2 divided by 2, then multiply by our du dx, which is 3. We'll now be having, we multiply them, we'll be having 3 u raised to the power of minus 1 all over 2 divided by 2. And we know that our u is 3x plus 5. From here, we say let u to be 3x plus 5. So finally, our dy dx will now be equals to 3 into 3x plus 5 raised to the power of minus 1 all over 2, everything divided by 2. So this is our final answer using the chain rule to solve this type of question. Question 2 is y equals to 3x plus u raised to the power of 3. From here now, so that we'll make one the solution, we'll substitute the function with x with u. So here our u will now be equals to 3x plus 2 because it is the linear function that have x. So we'll now be having y equals to u raised to the power of 3. Since we said our u is the same thing as 3x plus 2. So from here, you will differentiate u to respect to x, you differentiate y to respect to u. So that we'll be having du dx as well as dy du. That will substitute in the formula of chain rule. So differentiating u to respect of x, you'll be having du dx will now be equals to, if you differentiate 3x, you will be having 3. If you differentiate any constant number, you have 0. We will differentiate y again to respect to u to give us dy du, which will now be equals to 3u raised to the power of 3 minus 1. So our du dx will now give us 3u raised to the power of 2, 3 minus 1 will give us 2. And the form will now substitute them in our formula, which is dy dx equals to dy over du multiplied by du over dx. Our dy du is 3u raised to the power of 2, then multiplied by our du dx, which is 3. So we'll now be having 3 times 3 will give us 9u raised to the power of 2. But our u from here is 3x plus 2. So you substitute your u back, which will now give you 9 into 3x plus 2 raised to the power of 2. This is our final answer for the question 2. The question 3 is y equals to x plus 5 raised to the power of 8. We are still doing the same thing. X plus 5 is our inner function and 8 here is our outer function. We say that you will substitute any function with x by u. So in this case, our u will now be equals to x plus 5 and our y will now be equals to u raised to the power of 8. So from here, you will differentiate u again with respect to x to give us du dx, and you will differentiate y to respect to u to give us dy du. So our du dx, differentiating u to respect to x, if you differentiate x, you will be having 1. If you differentiate any constant number, you get 0. Then our dy du, differentiating y to respect to u, will now be equals to 8u, 8 minus 1, using the power law, which will now give us 8u raised to the power of 7. Then we've gotten our du dx and we've gotten our dy du. We now substitute it in chain rule formula, which is dy dx equals to dy du multiplied by du dx. Our dy du is 8u raised to the power of 7 multiplied by our du dx is 1. So everything you multiply by 1 will still be having 8u raised to the power of 7. Remember, our u is x plus 5. So you substitute your u back to your final answer, which will now give us 8 into x plus 5 raised to the power of 7. So this is how you can solve the chain rule. Firstly, locate the function with x and substitute it with u. The next example is on product rule. The question said, differentiate the following using the product rule. And even without telling us that we use product rule, we already know that we use product rule since they are multiplying each other from the name product rule. And the formula for product rule is f of x equals to u multiplied by v. We said the formula the derivative we'll be using is f prime of x will be equals to u v prime plus v u prime. So in any question you are solving in product rule, you have to look for your v, you will look for your u, you will look for your u prime and your v prime. Then you substitute it in this formula. And the v prime and u prime simply means the derivative of u and v. So the first question is y equals to x squared plus 4 multiplied by x cubed minus 1. So from here, this is our u and this is our v. So our u is now x squared plus 4 and our v is x raised to the power of 3 minus 1. So you will look for our u prime and you will look for v prime. So our u prime is, you will differentiate this function here. Our u prime is the same thing as du dx and our v prime is the same thing as dv dx. So differentiating x squared will be having 2x. If you differentiate any constant number, it will give us 0. So our v prime, we are differentiating this v here. If you differentiate x raised to the power of 3, you'll be having 3x 3 minus 1, which will give us 3x raised to the power of 2. So this is our u, this is our v, this is our u prime and this is our v prime. We'll now substitute it in our formula, which states that our f prime of x equals to u v prime plus v u prime. You can use v u prime plus u v prime, anyone, you still be having the same answer. So from here, our u is x squared plus 4 multiplied by our v prime, which is 3x squared. Then plus our v is x raised to the power of 3 minus 1 multiplied by our u prime, which is 2x. Then we'll now open this bracket. It will now be having x squared multiplied by 3x squared. We'll be having 3x raised to the power of 4 plus 4 times 3x squared will have 12x squared. Because 3 times 4 times 3 will give us 12. Then x squared plus x cubed times 2x will be having 2x raised to the power of 4. Then minus 1 times 2x will be having minus 2x. So we are having those ones that are similar. We are having 3x4 plus 2x4. We can add them together. So our will now be having 3 plus 2x4. We'll be having 5x4 plus 12x squared minus 2x. So this will be the derivative of the x squared plus 4 multiplied by x cubed raised to the power n multiplied by x cubed minus 1. So this is the answer for the first question. Moving on to the second question. The second question is y equals to x into 3x squared plus 5. So from here, our u is already x and our v is 3x squared plus 5. We'll look for u prime. Our u prime will be 1. If you differentiate x, you get 1. Our v prime will now be, if you differentiate 3x squared we will be having 6x. If you differentiate any constant number, you will be having 0. So inserting them in our formula, our f prime of x equals to u v prime plus v u prime, which now equals to our u is x multiplied by our v prime is 6x plus our v is 3x squared plus 5 multiplied by our u prime, which is 1. So from here, we expand it. X times 6x will give us 6x squared plus 3x squared plus 5 multiplied by 1. We'll still be having 3x squared plus 5. We are having x squared, we can add them together. So 6 plus 3 will give us 9x squared plus 5. So this is the answer to question 2 here. Moving on to question 3. Pause the video and solve the question 3 on your paper.